sad, sad day. And we are doing the last 3 problems. So this is 9.5, number 7G. Here we go. Mrs. Ford asked Michael to do 5 problems on day 1, 9, 13, and so on. If he did 538 problems on a certain day, did he stick to the plan? And if he did, which day was it? So basically, aren't we trying to figure out which term of this sequence 538 is?
Yes.
What kind of sequence is it? This is not a hard question. It's arithmetic, right? You have to be able to tell what you're dealing with so you know which formula to use. If this is arithmetic and I want to test a term, I'll use my arithmetic term formula, which is the first one we ever talked about. And what I want to know is there an n that would generate 538? So in other words, if I put 538 in as my last term, 5 as my first term, 4 as my common difference, because that's what's happening here in this sequence, am I going to get a whole number answer? That's really the key here. So let's solve that equation. I would probably, you can either distribute and solve that way. I would probably subtract the 5. And 533 divided by 4 does not seem optimistic. So that's 133.25 equals n minus 1. So if it were a term, it would have to be the 134.25 term. Is that possible? No. So the answer to the question is, no, Michael did not stick to the plan because this is not a term of that sequence. If it were a term of that sequence, n would have turned out to be a whole number. So if I got 134 as my answer, then that means it's the 134th term. But you can't have a fractional piece of a term. All right, the first term of an arithmetic sequence is 192. The 6th term is 7. Find the arithmetic means. David? The first one's supposed to be what?
It's not 192.
Oh, it's just 92. Thank you. That makes a huge difference. Thank you. Now, what we mean by arithmetic means is this is an arithmetic sequence. The first term is 92. I don't know the second, third, fourth, fifth, but the 6th one is 7. These numbers are called the means. They're the numbers in between the two that you're given. Now, actually, I think that formula right there is going to be very useful to me because they tell me this is arithmetic. I would have no way of knowing that if they didn't tell me. They tell me it's arithmetic. And according to the formula, the 6th term has to equal the first term plus the common difference, which I don't know, times 5. Remember, this is the 6th term. So n is 6. A sub n, a sub 6. So n minus 1 is 5. So now I can subtract 92 from both sides and divide by 5, and it looks like D is negative 17. Did you get negative 17? Now, obviously that's not the answer to the question, but now that I know the difference is negative 17, can I figure out what these terms are? Yep, so just subtract 17 and 17 and 17. This is risky. I'm trying to do this without a calculator. And 17 and 17. And these are called the arithmetic means. That's just how we just talk about the terms in between the two that you know. All right, that's easy enough. Last problem. The first, okay, so this is the same thing, only it's geometric. The first term is 120, and the sixth term, oh goodness, the sixth term is that. And we want to find the geometric mean. So we have 120, second, third, fourth, fifth, and then 39.3216. Now, we're not going to use the same formula we just used, right? Why not? Because it's geometric. So you're going to use your geometric term formula. And again, this is the sixth term. So n is going to be 6. So 39.3216 equals 120 r to the fifth. There's no way I'm trying this without a calculator. So we're going to divide by 120 first. So 39.3216 divided by 120. Okay, I have a decimal. 0.32768 equals r to the fifth. What do I need to do now to solve that? Oh, no, I don't think I'll use logs. Remember, we use logs when we have something like 5 to the x. When x is the exponent, that's when we use logarithms. Here, we just have to get rid of that 5. How do we get rid of that 5? Fifth root it. Yep, I'm going to fifth root it. And I have a fifth root button. Personally, I prefer to raise to the 1/5 power, but that's up to you. You can use your fifth root button. It's in your math menu. So I'm going to raise that to the 1/5 power. Oh my gosh, it came out to be 0.8. 0.8. So now can I find the rest of my terms? That was my job. So 120 times 0.8 times 0.8 times 0.8 times 0.8. And this will be the moment of truth. If I times 0.8 again, sure enough, 39.3216. All right. That takes care of that. Good work. Now, let me give you this little review sheet to help us get ready for our quest that we're taking next time.
So is the quest like the last thing, or is there something else after that?
Did your exam? No, the quest is Thursday. I don't see you again except for exam review. I was hoping, Grace, that I would get more in, but time got away from me. What do you think?
Is quest
You're so wrong.
over a day? 4.9.
Is the quest 9, 4, and 9, 5?
It is the entire 9, mostly 9, 4, 9, 5.
Okay.
All right, did everybody get one?
Sorry.
Okay. So here we go. You guys, this is in Schoology somewhere. The review, extra practice review in chapter 9. All right, so here we go. Someone threw a can away. All right, here we go. Let's see if we can get through this whole thing. Notice that in the title of the thing, I said mostly 9495. So you'll see as we go through these problems, it is mostly 9-4 and 9-5. All right, write 0.74 repeating. As a fraction in lowest terms. Okay, so remember this from the other day? This wasn't that long ago. We need to, first of all, separate the 7 because it is a part of the repeating. So this is going to be 0.7 plus, okay, the first repeating digit's right here, so 04 plus 0.004 and so on. So when I add, this is an infinite geometric series. What is the ratio? What's the common ratio? 0.1. Kids, if there's one repeating decimal place, it's 0.1. And there's only one repeating decimal place. So the sum here is going to be 0.04, that's my first term, over 1 minus my ratio. So that's 0.04 over 0.9. Now we're careful here, we got to move the decimal to remove the decimal, but we have to move it the same number of places. So that's going to be 4 over 90. Everybody agree? Now, you can reduce that if you want. I don't think I will, because I still have to add in this, right? And it's going to be easier for me to add 7/10 if I leave that denominator as a 90. It's not going to matter one way or the other. It's just how much work you want to do. So, get a common denominator here. So I have 4 90ths plus 63 90ths, which ends up being 67 90ths. And I always want to reduce if it does, but I don't think it does. So I think that's my answer. Would you agree? So now I'm going to just double check it since I have a calculator. I might as well. 67 divided by 90 should give me this decimal, and it does. All right. So now we have a kind of an old problem. Find the 7th term of this expansion. So we're not finding the whole thing. We're only finding the 7th term. So,
which page did you say this was on?
this is the review sheet practice quest for 9-1 and 9-5. So it would be in Schoology, Chapter 9, Extra Practice and Review. All right, so we're going to find the 7th term of this. The 7th. Okay. Now, if we were doing the whole thing, the first, remember, it has a coefficient, an x, and a 2i. Every term is going to have that, right? The first coefficient in the very first term for this expansion would be 9c9. The next one would be 9c8, 9c7, 9c6. And I'm going all the way to the 7th term, so I really don't want to write all those out. So 9, 8, 7, 6, 5, 4, 3. So the one I want is 9c3. Just by counting down, I want the 7th term. 9c9, 9c8, 9c7, da 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 da, till I get down to the term I want. Now, the exponent on this x would be exactly the same thing, because aren't I going to count down from 9 to get that? So that's going to be a 3, which makes this a 6, because I'm expanding to the 9th power. So 9c3, don't know what it is. X cubed times 64 y to the 6. The exponent goes with the number and the letter. So now I got to multiply these together. So I have 5, 3, 7, 6, x cubed y to the 6th.
Why is the x cubed?
count down, the first term would be 9. In the first term, it would be 9. 8, 7, 6, count down to the term you want.
How did you get 64 again?
2 to the 6.
So, why is 2y to the 6?
These have to add up to 9.
Where are you getting that?
Huh?
I'm just gonna be kind of confused, like, how do you get 2 in the first place?
Okay, in the very first term, if I were writing out the whole thing, the exponent on that would be 9. I'm going down to the 7th term, so I just count it. 9, 8, 7, 6, 5, 4, 3. The 7th term is 3. All right, I'm going to find the sum of this infinite series. What's the ratio? Divide by 9, that's what I'm doing, which means the ratio is 1/9. Remember, the ratio has to be a multiplication. You're multiplying by something. Just like the common difference has to be adding something. All right, so since it's dot, 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 it's infinite. My formula is that really easy one I used with the fractions. So the sum will be 45 over 1 minus 1/9, which is 45 over 8/9, which is 45 times 9/8, which is 405 over 8. So my answer is 405 over 8. Just a plug and chug problem. You have the first term, you have the ratio, plug it in, work it out. All right, number 4 is another kind of review problem. Find the probability of choosing exactly 2 hearts if you draw 3 cards from a standard deck. Now, pay attention to the fact it says find the probability. That means you're going to have a fraction. In the denominator will be 52C3 because I'm only drawing 3 cards, right? So in the other card problems you did, most of them it was a 5-card hand, so our denominator was 52C5. Well, this is exactly the same thing, only there's only 3 cards. Now, I want to get 2 hearts. Okay? How many hearts are in the deck? 13. And I want to get 2 of them. And what else do I have to get? Some other card that is not a heart. How many of those are there total? Not heart cards. 39. And I will need 1 of them. It's easy to forget this, and some of you did on our quiz. Some of you forgot that. It's easy to forget because it's not mentioned. You just have to know, oh gosh, I need 3 cards. So 2 of them are hearts, the other one's got to be something different. All right, let's go ahead and type this in, make sure we can. I think we can. You haven't really had time to forget yet, but let's do it. .1376 is what I got. Tell me if that's what you got. All right, there's one more kind of old problem here, and that's this next one. Jalen hit 6 free throws. Oh no, this is not old. This is new stuff. Jalen hit 6 free throws on the first day, 13 on the second day, 20 on the third day, and so on. How many will he have hit altogether in the first 82 days of practice. How many will he have hit altogether? What do I need to do here?
And the sum.
I need to find the sum. Is it arithmetic or geometric? It's arithmetic. So my arithmetic sum formula is the one Goss developed. It looks like this. And I want to add up 82 of these. Everything's great except what? I don't, this right here, this would be the 82nd term, wouldn't it? And I don't know it. So what am I gonna have to do? Go back to the formula I was using earlier. So the 82nd term will be the first term plus the common difference, which is 7 times 81. That's your arithmetic term formula. I got 573. Now I can actually answer the question. 573 is not the answer. That's how many free throws he did on the 82nd day. But we need to find the sum. So we're going to add that to 6 and multiply it by 41. So the actual answer is, 23,739. When we were going over this, we talked about that a lot of times when you use the sum formula, not so much geometric, but certainly with arithmetic, a lot of times you have to do this. Because a lot of times you don't know the last term. Okay? All right. Number 6. We need to evaluate the sigma. Sigma always means sum. So we're going to use one of our sum formulas. And we need to figure out which one we're going to use. So we need to figure out what the sequence looks like. So if I put in 1, my first term will be what? 3. If I put in 2, 5, put in 3, 7. Okay, well that's enough. I know what's going on. This is another arithmetic sequence, isn't it? So I'm going to use exactly the same formula that I just erased. I'm summing an arithmetic series. So the sum of 123 terms will be 123 over 2 times 3 plus. Now this is actually easier than the last time because when you're written in sigma notation, you can automatically find your last term, right? We're just going to plug that number in. So what is that? 246, 247? Did I do that math right? That's one of the benefits of having it in sigma notation. You know where you're ending. So then we just type it in. So 123. Oh, did you get 15,375? Yeah. All right, now we have some limits. Would you take a second, there's 6 of them there, would you just go through and fill in as many of them as you can, or take a guess at all of them, I guess, and see what you can get accomplished there? Yep. Well, I was plugging in, I plugged in 1, 2 times 1 plus 1, and then I plugged in 2, 2 times 2 plus 1. It does go up by 2, that's what I noticed, I didn't know that in the beginning. Alright, so go ahead, I'm gonna go ahead and take it 10 minutes while you guys are working on your limits. Oh wait, Josh, I have something for you up here. All right, how many of these do you have filled in? Anybody have any of them? What do you got, Grace? Give us one. A is, what'd you say? 3 over 20? 3 over 10? Let's see if she's right. What's the limit of the first part in problem A? 3/5. And it's a multiply. What's the limit of the second part? 1/2. So Grace said the answer was 3/10, and I think she's right. Okay? Who got another one? What'd you have? E is divergent? Actually, it is not divergent. Letter E is not divergent because the limit of 2 is 2, and the limit of that fraction is 3/2. So the answer actually would be 7/2. The limit of a constant is that constant. Okay? So when you have a limit of just a plain old 2, that's just 2. And then that fraction was 3/2 and it's added. So I'm going to add those together. So that's actually the answer to E. All right, who wants to try another one?
Is B 0?
With B, like as in boy?
Yep.
Yep, B as in boy is 0. And that one is 0 because why, Nicholas?
Because it's a fraction and it'll keep going down until it reaches 0.
Okay, now, it's not because it's a fraction, it's because it's a fraction, how big? Less than 1, that's the key. Yeah, it's a fraction less than 1. So if you keep, like he said, if you keep multiplying by a fraction less than 1, you just keep getting smaller. So that limit is 0, good. All right, somebody different. Why do you guys have your hoods on? We don't wear hoods in the building. Okay. Are you gonna redeem yourself, Tyler? Okay. Is F 0? Actually, actually F is divergent. Now, why is F divergent? If you FOILed out the numerator, if you multiplied it all out, your highest power would be n cubed. Right? You have other stuff, but it'd be n cubed. In the denominator, your highest power is n squared. So when you go to compare them, you have to compare the biggest power. So we don't have any on the bottom. So we're comparing basically 1n cubed over no n cubed, which would be divergent. Okay, does that make sense?
Divergent means no limit.
No limit. Yep, that's the math word for no limit. Read.
Would D be divergent?
D is also divergent because of what Nicholas was talking about. That fraction is bigger than 1, right? So there's no limit there. Those terms, if you started working them out, writing them out, they just keep getting bigger and bigger and bigger. Hector, the only one left is C. Do you have C figured out? Did you say no? Let's talk about it, Hector. What do you think we ought to do with that problem?
Would it be divergent?
Actually, it's not divergent. What's the highest power in the problem? The power of 2. And you've got a negative 2 of those on the bottom, right? Negative 2n squared? How many n squareds do you have on the top? None. So you have basically, you got other stuff, but you basically have no n squared over negative 2n squared, and that's 0. That's 0. Divergence is always a good guess, because it's going to be right for some problems, but you want to compare your highest powers. Okay?
Only so if we, instead of saying divergent, we just say none. Would that work?
Yeah, that would be fine. We're trying to talk like mathematicians. Let's face it, you guys are like minutes away from being a college calculus student. And those guys, those professors always want to talk like mathematicians. Okay. All right, one more problem here. It says a sub n plus 1 is 4a sub n plus 6. A sub 1 is negative 10. We want to find a sub 4. All right, who's got a thought? You have no thoughts? You should never admit
Plug
that.
in negative 10 for 4 a.m.
Okay, so yeah. Here's the deal, kids. If you just jumped in and said, I want to find a sub 4 right now, then if you were going to find a sub 4, wouldn't n have to be 3? And that would mean the equation would be 4a sub 3 plus 6. Do you know what a sub 3 is? No. So you're not going to be able to jump straight to a sub 4. In fact, what would a sub 3 be? A sub 3 would be 4a sub 2 plus 6. And you don't even know what a sub 2 is. All right, so what would a sub 2 be? 4a sub 1 plus 6. Now, do we know a sub 1? Yeah. So the way I've set it up, I'm working from the bottom up because I can't just find the 4th term. So a sub 2 will be 4 times negative 10, which is what Nicholas told us to do. And that's going to be what? Negative 34? Now, what's negative 34? A sub 2, the 2nd term. So now, can I find my 3rd term? So that's going to be 4 times negative 34 plus 6. Which is negative 130. Now, this isn't what I was looking for. This is the 3rd term, right? But now can I find what I was looking for? Yes, because the 4th term is 4 times the 3rd term plus 6. which is negative 514. So the answer to the problem is negative 514. That formula is different than the other ones we were using, because in the other ones, if you wanted the fourth term, you just plugged in 4. This doesn't work that way. This is what we call a recursive formula, and you have to build it to get where you're going. Okay? All right, so that takes care of that review. So having done that review, I still didn't get my attendance taken, so while I'm doing that, think for a second about what we need to do an extra practice problem of. While I take attendance here. Where is Michael Carnes?
I think he might be doing the AP test.
They don't have him marked. I mean, I'm not saying, I mean, he might be, but they don't have him marked. They don't have Oscar marked?
That happened last class.
What?
Last class, my teacher had the same
Oh,
problem.
really? Okay. Maybe they don't have them all in yet. Jacob?
Can I use the restroom real quick?
Okay, but you're supposed to be finding, some problems for us to work on. Okay, so they have Danica and George. Brenda's here, Josh is, Haley is absent. All right, have you found something for us to work on?
If I could use the bathroom since I found some questions. Thank you.
Yeah. Okay. All right, so Andrew has found something for us to work on. What do we need to work on,
Let's
Andrew?
go over 9.5 homework number 3.
So 9.5 homework, number 3. That sounds like it could be a quiz question. Let's see. 9.5. Number 1 or number 2? Homework number 1.
Number 1.
So this one says, we just practiced using a sigma, but this one says, write your own sigma. So I need to come up with 2 things. I need to come up with what we call an explicit formula or a general formula for right here. And I need to know what number to put up there on top. Now that one's going to be easy to find once I figure out this. What kind of a sequence is this? Arithmetic. And I know that the terms of an arithmetic sequence are the first term plus the common difference times n minus 1. So if I clean this up, I get 4n minus 2. That's what goes here. It's just the general arithmetic term for this particular sequence. First term 2, common difference 4. Now, I don't know what this last number is, but I know that if I plug it in, I get that, right? If I plug in 1, I get 2. If I plug in 2, I get 6. If I plug in this, I get 394. So what makes 4n minus 2 equal 394? What is that? 99? So there is my sigma.
or n minus?
This is my arithmetic series, or my arithmetic sequence formula. And the first term is 2, and the common difference is 4, so I just distributed and cleaned it up.
Oh, okay.
When you get a calculator for the question match.
Oh, you have to have a calculator. Well, I guess you don't have to have one, but it would not make sense to try to do it without. Grace?
Can you do number 2 on that homework? Does it have like the last term is like an infinite sigma?
Okay, so that means I just use my infinite geometric formula. So all I need for the infinite geometric formula is to know the first term and the common ratio. So can I find the first term of this thing? Sure. How do I find the first term of any sigma? Plug in 1. So if I plug in 1, I'm going to get 0. So the first term is just going to be 3. Now, how am I getting from term to term here? Think about it. If you put in a 2, won't you be multiplying by 4/5? Right? And if you put in a 3, you're going to be multiplying by 2 4/5. So we just keep multiplying by 4/5. So my ratio is 4/5. So that's my first term, and my ratio is 4/5. So if I want to add these up, it's infinite. There's no stopping it. First term is 3. 1 minus 4/5. That's 3 over 1/5. Which is 3 times 5, or 15. I was hoping somebody would come up with problems like we just practiced, that we need an extra practice one of. Yeah, are you two paying any attention back there? Okay. Grace?
Can you do another one of the work terms too?
Yep.
Like number 8 on the
Yep. So we have a formula that says, negative 2 a sub n plus 5 and a sub 1 equals 7. And we want to find a sub 5. Well, we just talked about it. Are we going to be able to go straight to a sub 5? No. We're going to have to build our way up. So we're going to need to find a sub 2. We know a sub 1 is 7. That one's already there. We're going to have to find a sub 2, a sub 3, a sub 4, and then finally we'll be able to find a sub 5. If you want to find a sub 2, which is the next one in line, you already know a sub 1 is 7. If you want to find a sub 2, then you're going to have to let n be 1, right, to get a sub 2. So then it's going to be negative 2 a sub 1 plus 5. But we know that's 7. So that's going to be negative 14 plus 5, or negative 9. So now we know what our second term is. Okay, so now I need the third term. Well, if I'm going to find the third term, then n's going to have to be 2. So that's going to be negative 2 a sub 2 plus 5. But I know what that is now. So that's going to be 18 plus 5, 23. Is that right? And then a sub 4, I'll have to let this be 3 in order, and be 3 in order to have 4. So that's going to be negative 2 a sub 3 plus 5, which is negative 46 plus 5, negative 41. And And finally then, I can find a sub 5. It'll be -2 a sub 4 plus 5. So 82 plus 5, 87 is our fifth term. Read.
Can we go over one, like number one on the review? The right.
Yep. Okay, so you're gonna write a repeating decimal as a fraction. So let's say our repeating decimal is 1.326. So 1.3266666. When we do this, using the strategy that we've been using an infinite geometric series, we have to separate the non-repeating part. So this is going to be 1.32 plus all of the repeating part. So the first thing that starts to repeat would be 0.006, and then 0.0006, and so on. That's the repeating part of the problem. Right? Okay? So I cannot add, this isn't part of the sequence because it's not repeating. So I need to add just the part that's repeating. So my formula says I take the first term and divide it by 1 minus the ratio. Now I have one repeating decimal place, 66666. So what is my ratio? 0.1. So I have 0.006 over 0.9, which, when I get rid of the decimals, because I have to, I'm going to move 3 places, so that's going to be 6 over 900. Now again, I know that reduces, but it's usually easier to not reduce yet, because I still have to add this in, right? This is the purple bracket. That's what the purple bracket adds up to. But I need that. So I have to add another 132 hundredths. Remember, we're making fractions here, so don't be adding 1.32. You're adding 132 hundredths. See how easy it is to get a common denominator? So I'll multiply by 9. And I'll have 6 900ths plus 1188 900ths, giving me a grand total of 1194 900ths. Now, I'm essentially done, but I do have to put it in lowest terms, right? So they both are divisible for sure by 2. So I have 597 over 450. I think I can divide by 3. So that's 199 over 150. I think I might be done with that.
Is it always going to be 0.1 on the bottom or not?
No, it's 0.1 on the bottom because we have one repeating decimal place. If there's 2 repeating decimal places, it's 0.01. I already talked about that today. It's tenths, it's decimal places. So however many, the tenths place is 1. The hundredths place is 2. So it just depends how many decimal places are repeating. So our answer would be this, and I would suggest that just for fun, you check that, and sure enough, it's right. Okay? Hector, you got any questions for tomorrow, or Thursday?
I got a question with like 132 over 100. Like, what do you get?
That is my 1.32. This is 1 and 32 hundredths. Remember, if you divide by 100, you have 2 decimal places, so it's the same as 1.32. I just have to make it a fraction so I can add it to this other fraction. Josh?
You got the 9 from the 0.9 under 0.06, is that correct? When you multiply?
Got what, 9?
Yeah, when you multiply the 9 right there, where'd you get that from?
To get a common denominator. I was adding 900 and 100.
Oh, that's right. Okay.
I'm adding fractions, so I have to have a common denominator.
Just totally fine.
Okay. All right.
That makes sense.
Oh, yeah. Yep. When that 4th grade teacher told you this was important, she was right. Yeah. Okay. All right. Next time we are going to have a quest and